Hi guys, a very good morning. This is Dr. Sajja Suneel from Data Science Department. Today I'm here to discuss you about IoT network and management systems, which is a continuation for our previous class. I already started discussing about this IoT network and management in my previous class. This was a continuation to those things which are going to be discussed in today's session, where we are having multiple things in this current module. As I told you, I have started discussing about SDN and network function virtualizer and differences between this SDN and NFVs where are shown in this concern module. And now in today's class, I am going to discuss you about the things such as network configuration, NetOpeer and Yang as well as SNMP, NetOpeer things in detail. Have a look guys how the things are shown to you. The main objectives of this concern IoT management and IoT networks are we need to improve the efficiency of reliability and scalable. We need to ensure how much reliable, how much scalable the connectivity was. And also you need to enable secure communication for providing the data management. You need to optimize the device performance and simplify the network management. What are the outcomes which are going to be achieved at the end of the day? At the end of the session, you guys are knowing about how to improve the operational efficiency. And you guys are knowing about how to enhance the security, scalability and growth. And also you guys are able to reduce the downtime and improve the customer's experience. This is how the objectives are going to be achieved at the end of the course. And in today's class, we'll start discussing about SDN. What SDN was? SDN is a network paradigm which is going to separate the network controls and data planes. And compared to the traditional networking architecture, here we are having a traditional coupled relationship between the data and control planes, which means the network devices such as routers, switches are the responsible devices for forwarding the packets and determine how the network is going to operate, right? This is how SDN is going to function. And coming to NFV, it is an approach to network architecture which involves replacing a dedicated networking hardware devices with software-based virtual network functions. And this is going to run on specific standards, and this is having a separate storage as well as separate switches in it. Why? Because virtualized network functions that are going to run on those particular things only. And coming to traditional network, in traditional network, special hardware devices such as routers, firewalls and load balancers are going to be used to perform a specific network functions. That is it about network function virtualization. And now we'll see the differences between SDN and NFVs. SDN stands for software defined network and NFV stands for network function virtualization. These are the both technologies that aim on the quality of network agility, network flexibility and network efficiency. By using these two technologies, we are going to calculate these things. And there is some overlaps which are happening between these two concepts. But there are some important differences also which are happening. And I will let you know some differences between this SDN and NFV. Have a look guys in SDN and NFV. What was the scope? SDN is primarily focused on the control and management of the network traffic flows. Whereas in NFV, which is going to focus on the virtualization and management of the network functions. Coming to functionality, SDN is going to separately control the plane from the data plane where data plane is going to be allowed for more flexible and programmable network. And coming to NFV, this network functions such as routing, switching, firewalling and load balances. Coming to deployment in SDN, it is typically requiring a specialized network hardware which such as switches, routers which are supporting open flow and other SDN protocols. And coming to NFV, which is going to be deployed on standard x86 servers, storages and switches. And coming to management and orchestration, SDN is typically relies on centralized controllers which are going to be managed and orchestrate the network traffic flows. And coming to NFVs, which also requires management and orchestration, but this is typically focused on the development and management of virtual network functions. And coming to the standards, SDN is primarily defined as ONF, Open Networking Foundation, and the Open Flow Protocol, whereas NFV is defined by European Telecommunication Standardization ETSI Institute. And this was the institute which is going to specify, which is defined NFV. And also NFV industry and specific group was there that also supports for defining this NFV. And coming to the network architecture, SDN, software defined network, is typically used to create a centralized software defined network architecture which is more programmable and very easier to manage. Whereas in NFV, on the other hand, it is focused on virtualized network where functions are going to create a more flexible and scalable networking architecture, guys. And coming to the network abstraction in SDN, this is going to abstract the network infrastructure from the control plane only by allowing the network administrator to define what are the different kinds of policies and configurations which are going to be used for separating from the underlying hardware. Whereas in NFV, these network functions are going to abstract from the underlying hardware by allowing them to be deployed and managed independently for the physical structure. And coming to the service delivery in SDN, it is going to enable the new service delivery models such as network slicing, and which allows network resources to be allocated dynamically based on the need and significance of the application servers. Whereas in NFV, it is also going to be enable service models by allowing the network functions, but it to be deployed and scaled up or down based on demand only. Whereas coming to the vendor ecosystem, SDN has larger and more mature vendor ecosystem than NFV. Why? Because it is having a wide range of products and solutions which are available from establishing networks as well as startups. NFV is still a relative new technology and the vendor ecosystem is still evolving. These are the things which are existed between the differences between SDN and NFV. Now, I will enter into IoT system management. Why an IoT system management is required? For configuring the systems automatically, for monitoring and operating the systematical data, for improving the reliability, for improving the reliability, and also for system-wide configurability and multiple system configurations and retrieving and reusing configurations. These are the specific needs which are required for IoT system management. Now we will start discussing this SNMP, what it is and how it works, what are the different pros and cons for this SNMP, Simple Network Management Protocol. What it is an industry standard protocol which is designed for network device management only. How it is going to work? Here we are using a manager agent model. The manager, NMS, network management station, is going to send a request to agent for running on devices to get information on MIB or changing configuration. NIB, which is management information based. MIB stands for management information based. NMS, network management station. And the important advantages are it is widely adopted and it is very easy to simply set up the things. Coming to disadvantages, it is having only limited data modeling capabilities where the security concerns are following still the old versions. So security factor was very low. Coming to the next thing, which is net configuration and YANG. This was considered as a powerful geo. Why? Because what these are, first you will know, after that I can say about this powerful geo. This powerful geo is going to configure the things on network devices. What network conf was? A protocol which defines how to communicate with a device for configuration management, which is very secure. It uses a very secure SSH transport and communication. Whereas YANG, which is a data model, net configuration was a protocol. ANG was a data model language which is used with netconfig to define the structure, how configuring the data for devices, how they work together. Netconf will provide the communication framework while ANG define what has to be done and how the data has to be exchanged. These are the things which has to be taken care by ANG model, what the data has to be exchanged and how the data has to be exchanged. The advantages of this powerful duo was it was more flexible, it was more secure, it is going to allow you to compare with the complex data modeling. The disadvantages are stepper learning curve, which is compared with SNMP. These are the pros and cons for this network config and Yang model. And coming to the next one, NetOpeer, SNMP NetOpeer. What it is a open source software which is suitable for network management. How it is going to function? It is going to provide specific tool for configuration management and monitoring. And also it is going to automate by using protocols like network config and simple network management protocol. And what are the benefits we are getting? Here we are offering with a comprehensive platform for managing the diverse network devices, including IoT devices, which are going to support our network configuration as well as SNMP, guys. This is how a network peer is going to function. Now we will see in detail what exactly this network configuration was. Network configuration protocol, it is a session-based network management protocol, which is going to allow you to retrieve the state and configuring data for manipulating the configuration on network systems. See, there was a client and there was a server. In server's end, there was a network configuration data store and ANG is defined to it. And now how the things ANG is going to define. It is going to configure the data and which operation has to be used in YANG. And whereas in RPC, remote procedural call, which is a kind of notification, and also we use a transport, right? These are the things which are existed in network configuration session-based management protocol, which allows us to retrieve or configure the data and manipulate the configured data on network devices. This network is a content layer which consists of configuration and stores with XML encoded. The main scheme of this configuration and stating data is defined in data modeling was YANG. And this network config is going to provide you a clear separation of configured state data. And that configured data is resided with network configuration on the server. This is how the network configuration is going to be done. And coming to YANG, which is a data model language, which is used to model the configuration and state the data when this protocol has to be utilized. And this YANG model, which contains the definitions of the configuration data, where it is going to state what was the remote procedural call which is issued and what are the format of notifications which it consists of, what that call consists of. This was the module which is going to define what kind of data to be exchanged between the net configure server and client in between them. And this was the module which is going to comprise the number of leaf nodes which are organized in hierarchical tree structure. This is how ANG is going to be get function. Excuse me. This ANG module is ANG version for toaster MIBs, management information base. And that toaster module is going to begin with header information followed up by the identity declarations which have various types. How these declarations are: the leaf nodes, toaster manufacturer, toaster model number, and toaster status, which is defined by the toaster container. And here each leaf node definition has having a specific type and how the description and default value was. This module has two RPC definitions. One is make toast, another one is cancel toast. These are the remote procedural call definitions which we say in a general. What are the basic thing in IoT system? How this IoT systems management is utilizing this network configure and ANG. First, you need to manage the system. The next one is how to manage the API, application programmable interface, and what transaction manager is going to do, what rollback manager is going to do, and what data model manager is going to do, what configure validator is going to do, what configure database is going to do, how to configure that application programming interface. how data provider application programming interface was there. These are the different kinds of things which we discussed at the time of our module 1 discussion, and along with that I will tell you how to do these things in a short term. The entire system has to be managed. That can be taken care by this management system. We need to manage the application programmable interface which is designed for managing the IoT devices. That can be taken care by this API. Transaction manager, who is going to manage the transaction which has to be addressed and which transaction has to be addressed next, and what transaction has to be executed currently. Everything can be taken care of this by transaction manager. Rollback manager, whenever we initiate a trade transaction, you need to roll back the transaction and to modify some particular content in it. Then this rollback manager will be helpful. What kind of model of data which we are utilizing, that can be taken care by this particular manager. How to configure the validator, whether the validator is a good one, how to validate the things in a good way, that can be taken care by this configure validator. And coming to database, how to configure the database, which is what data is existed in the database, how to configure the data by placing in a sequence, a synchronous way, right? And how the data provider, how to configure this API. If the API is configured, then automatically we will get an accurate result. Data provider API, how the data is going to be generated. IoT system with NetApp. Have a look, guys. These are the net configuration server where management API, transaction manager, rollback manager, data manager, configure manager, authentication and configuration database, configuring API, data provider. All these are ANG modulars. And coming to IoT devices, we are having managed objects, applications which are status of the application, statistics of the application, performance of the application, alarms and counters of the application. This is about how the management system is going to taken care of. With this, I can conclude one thing. You guys have known well about this IoT network and IoT management system. Now we have discussed these things for a better understanding purposes only. Kindly visit all my lectures which are there in YouTube for better understanding about this each module in detail. Also, I have explained this was a revision class to know about the things which are presented in this concerned module. I'll meet in the next class with the third module, which is controlling hardwares and sensors. Thank you, guys.
Like, share, and subscribe. Hit the bell icon for more updates.